what is a transformer and why is it such a big deal for natural language processing in particular?
Great question. So maybe we can break it down into a couple of steps. So at the high level, the transformer is just a neural network. And in particular, it's a deep neural network. So you've probably heard of deep learning kind of taking over software in the world in the last few years. And it was developed by researchers at Google around 2017, who were trying to find a more efficient way to do machine translation. And up until that moment, the sort of standard way of doing any sort of machine translation task was basically using a type of network called an LSTM. And these LSTMs, they have this kind of recurrent structure, which means that basically you want to convert one sentence into another. And so you feed in the kind of words from, say, the English sentence, and then this network would kind of iteratively process those words to then generate the translation. And these neural networks, they worked, these LSTMs, they worked quite well, but they had a few issues. And the major issue was that no one at the time could figure out how to kind of scale them, which means how could you increase the size of the neural network in terms of parameters? And also how could you train on, massive corpora? And so there were a few ideas floating in the literature at the time. Probably the most prominent one was something called attention mechanisms. And these attention mechanisms were also designed for machine translation, where the idea was when we're trying to process language, how can we encode some of the context that is surrounding the words in some phrase? So an example might be like if I say, my name is Lewis and I come from Australia, then we sort of can imagine there's some kind of correlation or some relationship between the word Lewis and the word Australia. There's some sort of connection between those two words in that sentence. And what this attention mechanism did, essentially it's a layer in a neural network, it provided a way to essentially teach neural networks how to model those relationships in a fairly efficient way. And so what the researchers at Google said was like, okay, maybe we can just take this attention idea and just train a network based entirely on this with a few other, tricks and things that were common in the literature. And the result they found was, first of all, a machine translation system that was state of the art at the time. But more importantly, it was something that could basically be parallelized on GPUs. So instead of having to use a kind of recurrent structure where you have to process sequences kind of word by word, you could basically feed in the full sequence, and then this attention mechanism would compute all these correlations, which would then allow the sort of model to be scaled up. And at the time, this was already like a big deal for machine translation. But then researchers at OpenAI, they took this idea one step further and they said, well, maybe we can actually just do this for sort of just general text generation. So instead of just having a single task like machine translation, what if we just train a transformer that's just very, very good at modeling the next word in a sequence? And this was the start of what was called GPT, or the generative pre-trained transformer. And in many ways, that marks the kind of start of this like revolution in transformers, where people eventually, saw, okay, this is both very good at generating text, and then as you scale up to the size of the internet and also to hundreds of billions of parameters, now you get these kind of models today, like GPT-4 and ChatGPT.
Yeah, really cool explanation there. I liked how you transitioned from LSTMs handling the sequential data to these transformers that have this attention mechanism that are able to take in the entire sequence at once. It's interesting how today I'm aware of a few different research strands that are now trying to blend these two kinds of approaches, because one of the big downsides of the transformer approach is that the larger the context window, so if you want to handle twice as many tokens, so roughly you can think of them as words, if you want to handle twice as many in your input, because the transformer needs to attend to that entire sequence, it vastly increases the amount of compute. So where LSTMs, because they work sequentially, as your sequence gets longer, the compute scales linearly. But with transformers, it scales polynomially. So like if you expand your context window by X, the amount of compute required goes up by X squared. So very, very quickly, way, way, way more compute is required if you have these bigger context windows. And so I'm aware of these research threads where people are trying to find some way of kind of blending the way that LSTMs worked with transformers so that we can get the attention on the full context window without necessarily that polynomial explosion in compute.
Yeah, that's totally right. And I think a lot of people kind of declared LSTMs were dead, with transformers. And um, I'm trying to remember the name of this latest model. It's got like a funny acronym, like I think like RKVMW or something like this. But basically it does exactly this. It tries to blend the kind of best of both worlds. So how do you have essentially infinite context length, but also have the parallelizability? And from at least the demos that this set of researchers have provided, you can see that they are quite competitive with, standard transformers today. So things that are like, llama and stuff. You see some of these LSTM hybrids at the smaller scales are quite competitive. And
Cool.
yeah, who knows? Maybe we'll see in a few years that it's not just a transformer that is the kind of key ingredient. But I think today most people kind of default to transformers just because the ecosystem has kind of become fairly commoditized. So
Mhm.
it's now relatively easy to fine tune transformers and getting easier now to pre train transformers. And I think there's a whole bunch of like tools around that, which, for these more research based projects, they often take a bit of time to kind of, coalesce in the kind of general practitioner's toolbox.